Hey guys, in this lesson we're going to look at creating 3D shapes using 2D shapes, and then we're going to take a look at cross sections of 3D shapes. So to start off with, to create 3D shapes using 2D shapes, there's a couple different ways you can do that. One of the ways we're going to talk about is rotations. You can take a cutout 2D shape, tape it to a pencil, and spin it. The shape that the edges make of that 2D shape is going to be the shape of your 3D shape. So if I were to take this 2D shape rectangle and put it on the pen, so to look at, here's the 2D shape, and then if I were to take it and rotate it like that, you'd be looking at the 3D shape. So looking at the first example, they give us the shape right here. The 2D is a triangle. Here's the pencil line L. And looking at the triangle, here's the base. And then here's the height. And what the problem is going to ask you to do is to identify the solid of revolution generated by revolving the region around the fixed line L. So rotating this triangle around 360 degrees in a circle, what shape would that make? And if you look, it's got a slant, so we want to look and see if there's a picture with a slant. The only one that does have a slant is this one right here, the cone. And something they can ask you to do is they can ask you to relate how the measures of the 2D shape relate to the three-dimensional shape. And if we look, the height right there is going to be the height right there. And they're going to want you to tell them what part of the cone is the height. And the height is going to create the radius on the cone. Whereas the base right there, it's going to go through right there and make the height of the cone. So that's what you would do if they would ask you to relate the dimensions of the 2D shape to the dimensions of the 3D shape that it makes. So if we try another one, identify the solid of revolution generated by revolving the region around line L. So if we look at this one, that one looks like a square or a rectangle. And if you were to take that and rotate that 360 degrees around, what shape would it make? Well, there's a curve, so that can be it. There's not a slant, so that can't be it. It might be this, but it's not long and tall. It's this one. So if we look and we relate our 2D dimensions to the 3D dimensions, this one's our height, right there, and this one's our base. And you can also identify your height as being right there. So the height on the square, looking at that shape right there, that's going to be a cylinder. The height of the square is going to make the height of the cylinder. And if we look at the base of the square, it's going to go from that edge to the center right there. So the base of the square is going to make the radius of the cylinder. Looking at the next one, we've got a curve. So we've got a half circle. And the only value that we could know for sure would be the diameter. I guess we could also know the radius from there to there. Yeah. So if we look, it can't be this one because it doesn't have any flat edges. So then we've got some options. We've got 3 different options we could go with. It's not going to be that one because the edge isn't cut off right there. So then it's a matter of this shape or that shape. And this isn't stretched out, and it's more circular than it is half an oval, so it's going to be the sphere right there. So 2D we had a half circle, 3D we have a sphere. And the diameter of our half circle is going to make the diameter of the sphere. And then the radius of the half circle will also be the radius of the sphere. And then looking at the last one, that shape right there, that's a trapezoid. And if we're looking at our trapezoid, there's the height. And then we've got base 1. And then we've got base 2. So if we take it and rotate it, it's not going to be that one, because otherwise it would be upside down. Not going to be that one because it'd be upside down. And then looking at those two, this one doesn't come to a point like a triangle would, so it's not going to be that one right there, so it'll be that one right there. So looking at our 2D shape compared to our 3D shape, base 1 is going to create, if you look at the bottom is going to be a circle now. So base 1 is going to create the radius of the top. Base 2, that right there is going to be a circle too. That's going to create the radius of the bottom. And then the height of the trapezoid is going to create the height. So there's a couple examples of identifying from a 2D shape how it makes a 3D shape, and then also comparing the 2D dimensions to how it makes the 3D dimensions. Looking at the next example of how we could create a 3D shape from a 2D shape, we could stack shapes. So we could cut out 2D shapes of all the same polygons. They don't necessarily have to be the same size. We'll talk about the two different options that we have. But taking all of the same polygons and stacking them. The shape that the edges form, the area that's going to be on the outside, that's going to be our 3D shape. And just a note, you can also stack 2D shapes that are the same size or different sizes. So if you and another word for same size is congruent. And another name for different sizes would be similar. So they're alike, but not all the same. So if we take the stack of congruent size 2D shapes, that's going to create a prism or a cylinder. So if you start with a rectangle, you take a bunch of those rectangles that are all the same size. Start with one rectangle. Take them all the same size and stack them. You end up with a rectangular prism. And you can do this with any shape. If this had been a triangle that you would start with, you would end up with a triangular prism. Okay. You can also do the same thing with a circle. You can take that one circle and make a whole big stack of them and make a cylinder. But they don't necessarily have to be the same size. You could take a stack of similar sized 2D shapes. So they have the same exact shape, but they're different sizes, either smaller or bigger, to create a pyramid, a cone, or a sphere. So if you looked right here, they took a bunch of squares and stacked them together. And if we looked at just the outside that this shape creates, you would end up with a pyramid. You could also do that with circles. If you take a bunch of circles and stack them together, the biggest to the smallest, you're going to make a cone. And then you could do it with a bunch of different sized circles and end up with a sphere. But you would have to go the biggest here whereas the biggest starts there at the bottom for those. It would have to go biggest to smallest, and then you would have to have a duplicate set of the same exact size and go biggest to smallest here. And that's how you could stack your 2D shapes to make 3D shapes. And the last thing that you could look at is cross sections of 3D shapes. This is the other part of the lesson today, is cross sections of 3D shapes. So a cross section of a 3D shape is going to be a shape that's created by cutting a 3D shape into two, and then the cut can be vertical, horizontal, or diagonal. So if you look, they give you the 3D shape that looks like a cube. If you take that cube and if you were to cut it into half, so if you were to take your cube and then cut it in half right there, they want to know what shape would you be left with. And if they make a cut that is parallel to any of the sides, so if they made a cut here, you could take a look at whatever the side is here, and that would be the shape that it would be. So they make a cross here, they make a cut here, and so as long as this cut is parallel to any of the bases or the sides, it's going to be whatever shape that side or base is. So looking at this is a cube, so that means this is a square, and if they make a cut across, you're going to end up with a square. They can do the same thing with a triangular prism. This was a cube. They can take a triangular prism, and using that triangular prism, they're making another horizontal cut right across through there. And since that cut is parallel to the base, all you have to do is look at the base, and whatever that base is whatever the cut's going to be. So here's the base right there. It's not a circle, it's not a quadrilateral, and it's not an ellipse. It's going to be a triangle. Looking at the next cut, these two cuts have been horizontal cuts. So they're looking at a horizontal cross section. Looking at this one, they've made a vertical cut. So when you're looking at the vertical cut, you've got to think, if I cut this in half, what shape is it going to end up with? It would have been easier had it been a horizontal cut, because then you could have just looked at the base and said that it's round. But when you cut a cylinder up and down, you're going to end up with a rectangle. You got to think of where's the outside of the shape touching the cut, or what's left, and that's going to be a rectangle. So this was a vertical cut. And then the last one is diagonal, and they could also call it oblique. It's just a math word for diagonal. And they take a square pyramid, and they're going to take the square pyramid and they're going to cut it at a diagonal. And if they cut it at a diagonal, that means this top side right here is going to be smaller than the length of the bottom side down there. So if we look at that, we've got a four-sided object where the top side is smaller than the bottom side. So top side smaller, nope, those are opposite sides are congruent. These are all the same. We don't have a triangle. We end up with a trapezoid. When you take a square pyramid and cut it at a diagonal angle, you're going to end up with a trapezoid. Now if we had cut it straight up and down, we would have had a triangle, because there would have been a point and it would have gone down this side right here to make another point, and down this side right there to make another point, so you would have ended up with a triangle. So there's you a couple different shapes of how you can find cross sections of 3D shapes. We also talked about how you can stack 2D objects to make 3D objects. And then we also talked about rotations of 2D objects to make 3D objects. If you have any questions from the lesson, be sure to write them down and ask them when you get to class.